Okay, so agenda for today, we have, we're going to go over our homework. I think it's very important that we go over the homework today because this was a not a usual Mr. Owen assignment, right? We're a little bit longer than normal. Usually I keep it short, sweet, and to the point. What I tried to do with this assignment was to start out simple and then build all the way into complicated. So using it as kind of like a teacher term would be scaffolding, like work our way towards the really hard problems. I noticed I had a couple hiccups in here. Hopefully I corrected that with you guys where I had the lack of an MPC on one problem and I had the number of the GDP was wrong on one. I corrected that for you guys, correct? Sweet. Corrected, correct. Thank you. Is that right? Right. Turn left? Right. Roger, Roger. So we'll go over the homework today. Then we're going to do a review game, try and get some concepts back in that we talked about earlier in Unit 3. Unit 3 was a very long time ago that we started this thing, so we'll get a couple concepts back. We're going to play a little bit of that concept game again, where we take a photo of the terms, and then we decide how to describe it without saying its name, see who wins. The lecture is short, but it's building on everything we've had, and this is it. This is the last lecture for this unit. Yeah. And then we're going to bring it all together with an FRQ. Someone added some eyeballs to my FRQ. Now it's just a Pinocchio. But we're going to bring it all together with an FRQ today, which means that, let's see, today is Wednesday. We're going to have Friday to review, and then we'll have Tuesday to review, and we'll be taking our test on Thursday. So today I'll get you guys a study guide. We'll do practice problems for the next 2 days. That way we have plenty of time to make sure we get this content down, because the ASAD model is the key to everything. But I like the fact that we have 2 full days to review for this material. Thank you so much. All right, so that being said, let's get page 1. Hey, they already got it up, but thank you so much. Do you need a note?
No,
Oh, cool. Do you guys need a note for your next class? Perfect. Okay, while I do that, do you mind? Whoop. Think fast. Whoop. And thinking quickly. And even faster. Whoop. Let's get 1, 2, 3, and 4 in the order in which you received your pins. Let's answer those on the board. Let's take a look at what we got. Number 1, the MPC in an economy is 0.15. MPC plus MPS is always going to add up to 1. So we subtracted here. So 0.85 would be the MPS if 0.15 is our MPC. Sweet. That easy one. Next one was MPS, and the economy is 0.8. Solve for MPC. So MPS, MPC equals 1. 1 minus 0.8, 0.2. You guys killing it. Those two were right there on the cheat sheet. Highly recommend just, writing those down on your study, not your study guide, your Scantron when you get that on the day of the test. If you receive 200 and you spend 20, solve for MPC and MPS. So this would be an increase in income of 200 and an increase in consumption of 20. So the MPC, 0.1, so MPS is 0.9. Cool, we are still with it. And then the next one, if you receive 400 and you spend 100, solve for MPC and MPS. So change in consumption over change in income. So our MPC is 0.25. 1 minus 0.25 would be our MPS, or 0.75. Awesome. So everybody cool with this so far? All right. The next one, I see how I definitely made a mistake on making this worksheet. What I probably should have done is put the years next to the charts. So I'm going to work that one out. Let me find my remote. If I was my remote, I would be right back here. So for next year, yes? Yeah, for that other one, if you're hit by a truck. Yeah, and I spent all the money. Yeah, the MPS was B0. This one I see, and I had a lot of questions come in about this one. This is my bad. What I probably should have done was make another column with the length of time on this one. Second semester people, it'll be on yours. But this would have been like, let's say, the year 2000, 2001, 2002, 2003, 2004. So these are years. This is the income you get. These are your expenditures, or we can call an expenditure the same. Let's get a better pen. The same as consumption. So consumption and expenditures, similar terminology. So the way to solve for this one is you have to look at, you're trying to find your MPC and MPS. MPC is a change in consumption over the change in income. So here, if we're going to look at the change in income between 2000 and 2001 was how much? I made $0 this year, and I made 20,000 in 2001. 20,000. So you graduated from college, you got an internship. That's still a pretty crappy internship. Maybe it's a part-time. Maybe it's a part-time internship. So right here, that's 20,000. My expenditures were $8,000. So probably there's some tuition in there or something. Your rent, your Netflix, your water, your gas, maybe daycare, whatever else you have as an expenditure. Originally, your autonomous spending was 8,000. Now our spending is 11,000. What's my change in expenditures? 3,000. So this right here would be a 3,000. So if I want to know my MPC, I'd say 3,000 over 20,000, which came out to be 0.15. And we solve for that on the first page, which means our MPS would be 0.85. Halvesies on that one. I used the change. I subtracted 8,000 from 11,000 to find the difference in expenditures, because I was originally making $0, which means my autonomous spending, autonomous consumption, means bills you have to pay no matter what, was 8,000. I was in a state of savings during this time period. I was living off my parents. I was using up my savings, etc. So here I have received 20,000 more of income. My change in income was 20,000. My change of expenditures was 3,000. So I put 3,000 over 20,000. That's the equation up here on the beginning of our sheet. Change in consumption over change in income. That ends up being 0.15 for my MPC. So then 1 minus 0.15 is 0.85. Does that make more sense? Okay. Just not hitting it hard today. That's fine. That's fine. Change in consumption, because I guess maybe I got lazy, or maybe it's because it's going to be like this on the test. It's going to basically be the same the entire time. The next year, 2002, I made $40,000. What's my change in income for this year? 20. Then I went up to 60. Then I went to 80. So it was always a change in 20,000. On this side, let's just get that 3 in the right spot, because I was trying to put it in between the two. So this was 3,000. Now it's 14,000. Then it's 10,000 and 6,000. So in each one of them, I'm just going to put the expenditures or the change in consumption over the change in income. So 14 over 20 gave me 0.7. My MPC. So what's my MPS? 0.3. Thank you. 10,000 over 20,000. 0.5. Awesome. Which means my MPS is 0.5. And then my last one, let's see, 6,000 over 20,000. I had 0.3, which means my MPS is 0.7. I realize I don't know. I think I might have skipped this slide for you guys. Did I skip that slide where I talked about what is autonomous consumption? I think it's because I skipped 2 slides in the beginning of the lecture and started with Uncle Sam fixing the pipe. What I probably should have done was explain autonomous consumer spending. Autonomous consumer spending or consumption spending is when you spend money that is required spending. Every month you have what are called required expenses that you have to pay. Rent or your mortgage, food, water, electricity, your cell phone coverage. What else can we not live without? Gas, car payments, Netflix. That's probably it. These are things we have to pay, probably pay no matter what. in this example, the income was 0 and the expenditures were 8,000. Now this is kind of a hard one to explain because if your expenditures are higher than your income, you're not saving, you're doing what's called dis-savings. And I try to think about how would I explain this to people. Back in the olden days with teaching, we got paid for 10 months, September through June, and then July and August. Yeah, July and August, you didn't get paid because you're not working. Nowadays, what we do is we get paid over a 12-month period of time. So you get paid in July and August. So in July and August in the old school method, when I was only getting paid 10 months out of the year, my income would be 0 in July. I wouldn't make any money, but I still had to pay for rent. I still had to pay for gas, Netflix, phone, car payments, all those other things. So during that period of time, I had to live off of my savings. So I was in a state of dis-savings. School districts got smarter and they realized that if they pay you over a 12-month period of time, they get to keep that income that they would be paying to you still in their account, collecting interest on it. Therefore, they're making more money on our salaries and they pay us slower. They're benefiting from it. I also benefit from it because remember, my MPC is very high. I have no ability to save, right? This forces me into a state of safety, right? Because if I had to save my money for 2 months, and like have it sitting there like, oh, I sure hope that's saved, right? Uh-oh, Mr. Owen would be eating top ramen like it's UCSD again. Yes?
So when it asks what is the autonomous consumer spending, you're not going to give it a number. Oh, it is a number. So it's whatever you spend when your income's 0.
So this one is showing that we had to spend this no matter what. And so even though my income was 0, I still had to make payments. So next year when you're in college, you're going to have autonomous spending. Like you're going to have to pay for your books, your food, and stuff like that, even though most of us probably won't have a job. If you do get a job, get one where you get a good benefit from it, like free food, something you like, Shoot, I was recording that. Okay, so the next one I think we can jump at as a class. Let's get some pins out. Okay, part 2, sorry, bud. Part 2, we had we're solving for the MPC and solving for the MPS. I took the format from our sheet and I love the snipping tool, and I used some snipping tool to put them next to each other to try and prove a point with this one. Josh, Emily, and Nico. You guys are on, sorry about that footstep there. You guys are on. Okay, perfect. So you guys nailed this. On this side, we had 1 over MPS for our MPC. So 1 over 0.52, 1 over 0.254, 1 over 0.2 was 5, and 1 over 0.1 is 10. Our spending multiplier is always 1 over MPS. So 2, 4, 5, and 10. And then on this side, we went MPC over MPS. So 0.8 over that's 0.5. Sorry. I thought that was an 8. My brain just stopped. So 0.5 over 0.5, 1. 7.5 over 2.5, 3. 0.8 over 0.2 was 4. And 0.9 over 0.1 is 9. And so what I'm looking at here, and I put them next to each other now, that we can see that your your spending multiplier is always 1 higher than your tax multiplier. That's the super cheat. See that? So if you memorize one of the equations, 1 over MPS or MPC over MPS, you're going to see that spending multiplier is 2, tax multiplier is 1. Spending multiplier is 4, tax multiplier is 3. Spending multiplier is 5, tax multiplier is 4. Spending multiplier is 10, tax multiplier is 9. So you just need to remember 1. And the reason that happens is because, remember, when we are going into a fiscal policy, when government decides to start spending, that first round of spending for government spending counts here in government spending. And then every subsequent round of spending occurs from our C and all the way until it hits 0, right? So this counts in our GDP. Then every round after is a consumer spending based off of our marginal propensity to consume or save. Government spends $100, he saves part of it, spends it, he saves part of it, spends it, he saves part of it and spends it, and so on and so forth until there's nothing left. On the tax multiplier side, it's all coming from this guy right here. So when you get a tax cut, the first thing that happens is, hey, the first consumer sees their paycheck. They go, whoa, I got a tax cut. I've got more money. Cool. I'll save some of it and then spend it. Then save some of it and spend it. Save some of it and spend it. Save some of it and spend it. So they missed a whole round of spending, which happened on the spending multiplier. That's why our spending multiplier is always one higher than our tax multiplier. Solid. Okay. So now we have multipliers all figured out. We can move on to a little bit more exciting stuff. In this setup, orange is not going to work. Let's go with red. In this setup, the current MPC is 0.8. What's that line doing there? What is that line? Is it a mouse? Wow. Cool. You just solved that. That's going to bother me for days. Thank you for saving brain power. So the current MPC is 0.8 and the economy is experiencing a recessionary gap. Apply the multiplier effect and your knowledge of fiscal policy options to determine the net effect of each of the following and determine which of the following options is most likely to have the greatest effect on the economy. So we're in a recession. If we're in a recession, we want to have some type of expansionary fiscal policy, right? So expansionary fiscal policy, we have two options. We can increase our government spending or we can decrease our taxes. These are the two options that we have. Each one has a different multiplier, spending multiplier and a tax multiplier. We were given this number right here. So MPC is 0.8, which means our MPS is 0.2. So my spending multiplier is 1 divided by 0.2 or 5. And I don't want to waste time thinking. I just know my tax multiplier is 1 less. So now we know that, we can use this equation right here. Our total change in GDP is our tax multiplier, snipping tool, or our spending multiplier, times our initial change in taxes or spending. So in this situation, we have a 50 billion decrease in taxes. This one, we have a 50 billion increase in government spending. Here we have a decrease in $60 billion worth of taxes. And we have to find out which fiscal policy would be the most effective. Who hasn't gone yet and feeling fancy and comfortable to do some math? Yeah, Derek, thanks for volunteering. And thanks for volunteering him. Okay. So we had the first option we had of our first fiscal policy was a 50 billion decrease in taxes. A decrease in taxes is going to increase our aggregate demand. I always like to put a plus next to it. That way I remember. So in this case, 50 billion times our tax multiplier, because we're doing total change in GDP, equals our tax multiplier times our initial change. So our initial change was 50 billion times our tax multiplier is $200 billion. We good with that? Solid. B, a 50 billion increase in government spending. So here we have, this is 50 billion times our multiplier, which was 5. So 5 times 50 billion equals $250 billion. All right, we're looking good. And I probably should have added this. I just moved too fast. If it's an increase in government spending, that's moving aggregate demand to the right, so it's a plus. And then our third one, 60 billion decrease in taxes. Decrease in taxes is still, that's a fiscal policy. So 60 billion times our tax multiplier. So 60 billion times our tax multiplier equals 240. Which of the following is the best option for government to use to get out of this recession? B. So B was the best option. Yes, question. Of course. Of course. Yeah, actually, C is looking good, but I'll talk it. I love talking. It's the only place where people listen to me. So, oh, that was on the recording. Okay, so we were. That's okay. That's okay. That's why I did this in the beginning because that was my bonehead move. Remember, on the AP exam, you're not going to be allowed a calculator. So all of the math, like all of the MPCs are always going to be zero 0.8, 0.75, 0.5, 0.2, or zero 0.9. It's only going to be stuff you can solve in your head. The idea that I originally did 0.08, that's just wasting your time. So sorry about that. So let me talk out B real quick, and then I'll get to C. So B, we have a 50 billion increase in government spending. An increase in government spending is an expansionary fiscal policy to move aggregate demand to the right, right? And they're going to spend 50 billion. So if I'm using this equation up here, if I have my total change in GDP equals my spending multiplier times my initial change in GDP, what do I know? My initial option was 50, so I've got 50 billion. My spending multiplier, because I'm using government spending multiplier is 5. So 5, sorry, that's supposed to be a 5. 5 times 50 billion shows my total change in GDP of $250 billion. Does that make sense? I'm just plugging into this equation. Who asked on B? Did that make sense? Basically, I'll slow it down. I'm talking too fast. So check this out. Our economy is in a recession. You guys, this might help other people in the classroom. I know there's a lot of side conversations and calculus going on right now, but take it down a notch. Our economy is in a recession. We're sitting over here where our quantity of equilibrium is less than our quantity at full potential output. We have our aggregate supply, we have our aggregate demand, we have a long run aggregate supply. This is our price level. I'm just doing all of it that way. It's authentic. This is our price level at equilibrium. We're in a recession, right? We need to be at full employment. This is where our economy wants to be, but we are producing here. So what we're trying to do is increase government spending to move aggregate demand to the right. We have 3 options to work with. Either we decrease taxes by 50, we increase spending by 50, or we decrease taxes by 60. And so what I'm trying to do is figure out what has the highest total change. So I'm using this equation right here. I use my tax or spending multiplier times the initial change. So what they're saying is, I'm in this spot. I need to get to this spot. What is going to be the most effective tool to get there? And in this case, this had the highest total change, 250 billion. That would move us over from here to here. So this question, it was all about assuming we're just in a recession. Later on, you're going to get a number like 400, and then we're at 100. We're going to have to increase our GDP by 300 to close the gap. Right now, we didn't do that step. We just said which one's most effective, because they love to ask you on the test something like, if government spending is increased by 50 billion and taxes are decreased by the same amount, which one will have a greater effect on the economy? It's always going to be the government spending, because it has the larger multiplier. So basically, I'm just trying to prove a point through a whole bunch of problems. Cool. Can I do C? Or do you get it? Yep. She did the exact same thing that I said. She just left out initial change. So the total, so change in GDP equals the tax multiplier times the initial change. And in the initial change in this one, the government's like, well, what if we cut taxes by 60 billion? So if we cut taxes by 60 billion, all these people are going to have more disposable income. Therefore, they're going to buy more stuff and aggregate demand shifts to the right. So here it says the total change in GDP equals our tax multiplier times initial change. So the tax multiplier is 4, and the initial change was 60 billion. 6 times 4 is 250 billion. What did I just say? 240 billion. Wow. Numbers in my head don't work. Does that make sense now? Cool. All right, so it got a little bit more complicated, but now we are analyzing 3 different choices that the government could do to solve a recessionary gap. Is it okay if I do this one and then I'll pass out the pins for the next question? All right. Okay, this one says, assume that an economy has an MPC of 0.75 and Congress decides to increase government spending on infrastructure by 50 billion. Solid, that's nice. They're going to build a tram going into UCSD. In an effort to balance the budget, they increase taxes by 50 billion. This time, this is going to negatively affect our aggregate demand, right? Because increasing taxes is a contractionary fiscal policy. So we have an expansionary fiscal policy and a contractionary fiscal policy on this one. You got to make a cameo. So in this case, we need to know what our 2 multipliers are. So at 0.75, our spending multiplier is 1 over our MPS. So our spending multiplier is 4. And our tax multiplier is MPC over MPS, or we know it's always 1 smaller. So it's 3. This one, we're going to say, okay, what is our total change in, and they want to know, in addition to improving the infrastructure, the sweet tram at UCSD, what's going to happen to GDP as a result of this one? And I'm going to change my pen because that was looking nasty. So first, let's see what happens to GDP as a result of the spending on the tram. So total change equals our multiplier times initial change. How much do they spend? 50 billion, right? So they spent 50 billion. My initial change is 50 billion. What's my spending multiplier? 4. So what's my total change? 200. So we have an increase in GDP of $200 billion. Now let's figure out what happened as a result of the increase in tax. So I've got total change equals my multiplier times my initial change. How much did they increase taxes by? 50 billion. They wanted to balance the budget. So they increased taxes on everybody by $50 billion, which is going to be a negative, right? Because that's going to negatively affect our aggregate demand. What's our multiplier? 3. So what's my total change in GDP? 50. So my total change in GDP is $50 billion. So let's negative $50 billion. So 150. Why do you shout things like that? I just believe you back there. Oh yeah, wait. Yeah, okay. So 150, negative 150 plus 200 is 50. So what happened to the GDP as a result of this whole thing? Our GDP increased by $50 billion. We had an expansionary fiscal policy and a contractionary fiscal policy. Why they do that? Because this is a fiscally responsible government, and if they're going to spend $50 billion, they didn't want to just borrow that, right? So what they do, they spent 50, but they raised taxes by 50, so the budget was balanced. Is this a real life scenario? Oh heck no, right? Is our budget balanced right now? Oh no, it's going crazy. So that's a real world situation in which you increased your spending and increased your revenue by the same amount, and it actually had a positive effect in the economy, and UCSD got a tram. I know I'm obsessed with this tram, and I talk about it every day because I drive past it every day on the 5, and every day I see like which, piling they've got built up. I always wonder about like how La Jolla Country Day is going to feel about it because it goes like right over their school and all those houses. No one's been down that way to see it, huh? It's it's pretty awesome. I think it's pretty awesome. I'm obsessed. And let's be honest, my traffic is so bad on the way home. I'm looking at everything. I'm like, hmm I live downtown. Yeah, it could definitely happen. That's when we'd end up deficit spending. Yeah. Let's hold on to that thought for a minute because I'm recording. Okay, so judging by the responses I'm getting so far, I feel like I'm gonna pause the video right now and we kind of engage in these. Let's do these. Yeah, I know that's a stupid word to use. Let's get after our own questions on our sheet because I feel like up to this point, it's maybe this isn't sinking in as well as I thought it would. So let me pause this bad boy. Here's what we got with this question right here. It says that our potential output is 800 billion, which our potential output lives underneath our long run aggregate supply, right? Our potential outputs are QY. So if our potential output's $800 billion, and it says our current GDP is at 850, so our QE is at 850, we're sitting right there. What kind of gap we in? Inflationary, right? Inflationary gap. So the government has two options to fix an inflationary gap. Well, I should probably put some stuff on here like an aggregate supply and aggregate demand. We have two options. We can decrease government spending, or we can increase our taxes. This one says, assume the marginal propensity to consume is 0.8, and this is where we're at. A policy of increasing or decreasing government spending. Ooh, okay, well, that's easy. We know that's this one. So we're going to decrease government spending by how much would bring us to potential output. We want to get here. What is our inflationary gap? $50 billion. So our total change needs to be $50 billion. So we've got total change in GDP equals our multiplier times our initial change. We got to cut some spending. First, we got to figure out our multiplier. Our multiplier, if we've got an MPC, let's keep this all in the same spot. That way I don't get crazy. If we have an MPC of 0.8 and our MPC, our MPS would be 0.2. So my spending multiplier is 5 and my tax multiplier is 4. So here I'm going to decrease spending by a multiplier of 5. My total change needs to be $50 billion. So what is my initial change? $10 billion. We just have to cut spending by $10 billion. The math is not hard. It's just remembering all those terms we talked about up to this point. That QY is our potential output. That QY means long run aggregate supply. That our current GDP is our QE, or our short run equilibrium. Yes? It'll be in a multiple choice. It'll be there for you. No, that's entrapment, my friend. Yeah, that's illegal. So the question was on a test, do we put -10 or 10? And my response was it's going to be a multiple choice question because it's going to be this is definitely on there. I'm repeating the questions because they can't hear you because it's coming out of my jawbone. I'm looking at you and nodding.
But that doesn't make sense with the negative, because if current decreased government spending by, okay,
If government spending increased by 20 billion, resulting in an equilibrium output increasing by 80 billion, what is the value of the MPC? Now that is some math. This time we've got our total change equals our multiplier times our initial change. We know that our total change here is going to be $80 billion. Our initial change is $20 billion. So what's our multiplier? 4. So our multiplier equals 4. So if our MPS is, let's see, 1 over MPS equals 4, what's our MPS? 0.25. So if our MPS is 0.25, what's our MPC? 0.75. Math just hit you in the face. That's the most math in the entire class. That was it. That's as intense as it possibly can get on that one. Assume the economy has an MPC of 0.9. Government increased spending by 20 billion and cut taxes by 5. Wow, they are getting after it. How would GDP be affected? So at this point, we've done enough multipliers to know that this is 10, right? 1 over MPS. So my spending multiplier is 10. My tax multiplier is 9. If you're like, why? Because MPS equals 0.1. 1 divided by 0.1 is 10. 1 less than 10 is 9. Government increased spending by 20 billion. So 20 billion times 10 equals 200. And then cut taxes by 5. So 5 times 9 is 45. What is the total GDP affected? 245 billion big kerschmackers. All right, there's one more to go. Assume the question. Assume the economy of Falconia has an MPC of 0.75. We already know where this is going to go. They want multipliers. So 0.75 we know is going to end up being a spending multiplier of 4 and a tax multiplier of 3. If the government raised taxes, so that's a decrease, and decrease spending. Oh, 2 negatives don't make a happy town. 2 negatives, so they raised taxes by 1 billion. So 3 times 1 is 3, and they decrease spending by 5. 5 times 4 is 20. So it would be a shift of $23 billion. Aggregate demand would shift to the left by $23 billion. Cool. Is this making sense now? Yes. No problem. No problem. No problem. No problem. Okay, we have one more question. This was the bring it all together into a graph that if I wanted to assess all student learning in Unit 3 that has to do with aggregate supply, aggregate demand, maybe even a Phillips curve, the use of a multiplier, everything wound up into one magic thing, it'd look like this. You picking up what I'm putting down? Yes. This would be something that would be so awesome. I love this question. I love it so much. I'd love to see it again on November 13th. Oh, maybe November 14th too, because this is even. No, wait, is this odd? We're on odd. Okay, here we go. I'm just going for it. Or do you want to try and chance to do it by yourselvesies? You haters. All right, I'm going for it. Owenville has a potential output of $50 billion. Where does potential output live? On the long run aggregate supply. Its address is LRAS. So 500 lives right here in Happy Town. We are in a short run equilibrium of 450. Oh no! 450. That's so sad. We're right there. Oh, we're going to pretend that was a straight line. Price level, real GDP, aggregate supply, aggregate demand, price level, equilibrium. Okay, so we check the box for A, solid. Assume the government cuts taxes by $5 billion. Okay, so they're going to try. Why would they cut taxes? Well, because they're trying to fix this, right? So they cut taxes by $5 billion to close the gap to potential output. The government should also increase spending by how much? Woo, that's fun. Let's solve out for our multipliers. If our MPC is 0.8, our MPS is 0.2, so my spending multiplier is 5, my tax multiplier is 4. So the government decided to cut taxes by 5 billion. So total change equals my multiplier times my initial change. My initial change was, I know my short-term memory is really staggering today, is 5 billion. My multiplier is 4. So they moved us 20 billion. Cool. So that got us to about 470. Solid effort, government. You got us to about right there. We still have a smaller gap that needs to be closed. Instead of 50, now it's 30. So in this case, now I've got to use my spending multiplier. This time I know that my total change needs to be $30 billion. My multiplier is 5. So what is my initial change? $6 billion. So $6 billion would be my initial change. If that happened, my aggregate demand would come all the way here. They wanted me to label that as aggregate demand 1. Check. 6 billion. Check. Graph at label 81. Cool. Bonus. Use a Phillips curve. Oh yeah. Phillips curve. Unemployment. That was definitely on the tape. Oh my. Solid. We started out right there. Long run Phillips curve. And now we're at B. Cool. Was that actually kind of cool? It's putting numbers to see what government would actually do. Now, this all assumes that people would logically spend the money or save the money. Do people make rational decisions? No. And this is a tough one. And today's lecture is that we are going to explain the problems behind fiscal policy. Let me pause this bad boy.